All right, let's get right into it. The world of robotics today is just electric. You see these billion-dollar companies popping up, you hear people talking about a whole new technological revolution. But there's a catch. We're running into some very old, very stubborn physical problems. So in this explainer, we're going to slice right through that noise and look at the wild hype versus the tough reality of the hardware.
And this hype, it's coming from the very top. I mean, tech giant NVIDIA recently stood up and called this the ChatGPT moment for robotics. What they mean is that the software, the brain, is having this incredible breakthrough. You've got AIs that can see the world, understand plain English, and then command a physical body to act. That's the idea that is fueling this entire gold rush.
Which, of course, brings us to the real question, the one that matters most. Is the actual hardware, the nuts, the bolts, the motors, is any of it truly ready to cash the checks that the software is writing? To figure that out, we actually need to take a quick step back in time. You know, this dream of having machines do our work for us, it's not new, not at all. It's an ancient human ambition. So let's do a super fast tour through a couple thousand years of history to see how we even got here.
I mean, think about this. All the way back in 100 BCE, the Greeks built something called the Antikythera mechanism, basically a mind-blowing analog computer. Fast forward over 1,000 years, and the inventor Al-Jazari was designing little automated figures to serve drinks. We didn't even get the word robot until a Czech play in 1920. But the modern world really began in 1961 when the very first industrial robot, a beast named Unimade, started lifting hot metal for General Motors.
Okay, so that's the dream. Let's pivot to what's real. Where are robots actually working, at scale, in our world today? The answer might not be what you think.
The sheer number of factory robots out there is staggering. But what's even more wild is the split. As of 2024, China has 2 million robots working in its factories. The US, just under 400,000. That is a 5-to-1 difference. It tells you everything you need to know about where the center of gravity for industrial automation is right now.
But the robots themselves are changing big time. We're moving away from those giant, caged-off industrial arms that just replace a human. Now we're entering the era of cobots, collaborative robots. The whole idea is that they augment human skills. They work right next to people, safely. It's a shift from replacing us to helping us.
And this new approach is finding huge success in some key areas. Amazon has over 1 million robots zipping around its warehouses. More than 60% of big hospitals have surgical robots. And those little Starship delivery bots you see on the sidewalk, they've made over 8 million deliveries. This isn't a pilot program. This is the real deal.
So what's the magic trick behind all this? It's a new kind of software called a Vision Language Action Model, or VLA. To put it simply, the AI can see with a camera, understand a normal sentence like, "Hey, can you grab me the red apple?" and then figure out the exact physical motions to go and do it. This is that software revolution we were talking about.
Okay, so the software is getting brilliant, and specialized robots are absolutely crushing it. But what about the one we all picture, the Holy Grail, the general-purpose humanoid robot? Well, this is where the hype slams headfirst into a wall of very hard problems. Time for a reality check.
The money involved here is just astronomical. One humanoid robotics company, Figure AI, recently raised funds at a $39 billion valuation. That is a planet-sized bet on a future that is nowhere near here yet.
And here's the disconnect in a nutshell. A $39 billion valuation for a machine that can typically run for about 90 minutes. 90! A standard shift in a factory is 8 hours. The chasm between the financial hype and the physical reality is just immense.
And we saw this play out perfectly with Figure AI's big pilot at a BMW factory. On paper, it was a huge win. The robots worked long shifts, they helped build thousands of cars. But then what? Well, after the pilot, Figure admitted they found hardware failures and pulled out. BMW said there was no definite timetable to use them for real. So the demo worked, but the robot just wasn't ready for prime time.
It's become clear that humanoids are hitting a serious hardware wall. It's not just the batteries. There's what they call the dexterity gap. Believe it or not, the hands on these robots are basically no better than they were 40 years ago. There's a huge reliability problem. Something that works 95% of the time in a clean lab might only work 60% of the time on a messy factory floor. And the AI brain, as smart as it is, often can't think fast enough for smooth, quick movements.
And look, you don't have to take my word for it. The Wall Street Journal ran an article with this incredible headline. When the people actually building the machines are telling you that the hype has gotten out of control, you know it's real.
Now, even with all these challenges, the tech is moving forward. And as these things get smarter and closer to our lives, we have to realize the engineering problems are only half the battle. We've also got to figure out the ethics. We need to write a rule book for these things.
For pretty much everyone, our whole idea of robot rules comes from science fiction, right? Specifically, Isaac Asimov's famous 3 laws from way back in 1942. You know them: protect humans, obey orders, protect yourself. They're elegant, and they've been the bedrock of how we imagine robot ethics for decades.
But here's the thing. Asimov's laws were for telling stories. As we go from science fiction to the messy real world, we need a framework that's way more practical, one that can actually handle all the weird complexities of reality.
And that's what's happening. Experts are developing modern principles that totally shift the focus. Instead of trying to program morality into a robot, the new idea is that humans are always the responsible ones. It has to be crystal clear who is legally on the hook for a robot's actions. It's a huge shift from robot morality to human accountability.
Which brings us right back to where we started. Robotics is at this totally fascinating make-or-break moment. You have the software, the AI, advancing at a blistering, incredible pace. But the hardware, the batteries, the gears, the hands, it's still stuck playing by the slow, stubborn, unforgiving rules of physics.
And that leaves us with the big, unanswered question for the next few years. The artificial intelligence is learning at lightning speed. It's making promises left and right. But can our physical machines, our hardware, actually keep up? The answer to that is going to define our entire relationship with technology for a generation.